Let's look at some 9.5 real world examples. So this example I created here, it's not in the textbook or anywhere, so if you want to copy it down, just pause the video and take a second to copy it down. It says, Lewis tosses a ball up to Quincy, who is waiting at a third-story window. The equation h equals -16t squared plus 30t plus 6 represents the height h of the ball after t seconds. If the ball must reach a height of 25 feet for Quincy to catch it, can he catch the ball? So let's think about what this question is actually asking. It's not asking necessarily what is the height of the ball or when will the ball reach a certain height. It's just asking if it's possible for him to catch it at a height of 25 feet. In a question like this, I could do the quadratic formula and I could figure out exactly what time the ball would reach a height of 25 feet. But to be honest, that's a waste of time because it's not asking us to find the time. It's just asking us, is it possible? Can he catch it? So for a problem like this, we're only going to use the discriminant. We don't have to do the whole entire quadratic formula to see if it's possible or not. We're just going to use the discriminant and see what happens. If our discriminant is positive, then there are two solutions. So yeah, he has two chances to catch the ball, on the way up and on the way down. If the discriminant is 0, then there's one solution, which means it'll reach exactly 25 feet and he can reach out and grab it. But if the discriminant is negative, then it's not possible for him to catch the ball. So let's go ahead and start with what we have here. We have our equation and we have our height of 25 feet. Let's take the 25 and let's plug it in for h in our equation. So we're going to start with our equation as 25 equals -16t squared plus 30t plus 6. Remember, when we start working with the equation, it has to be equal to 0 first. So let's start by subtracting 25 from both sides. So now our equation is 0 equals -16t squared plus 30t minus 19. Now we're ready to plug this into our discriminant formula. Here's our A, B, and C. Remember, our discriminant formula is d equals b squared minus 4ac. It's just the expression under the radical in the quadratic formula. Let's take our numbers and let's plug it in. We're going to get d equals, our b is 30 squared, minus 4 times -16 for A and -19 for C. When I simplify, I'm going to get d equals 900. This is a negative, 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 so our product is going to be minus, multiply these numbers together, I get 1216. Let's subtract these numbers and I get our discriminant is -316. Now let's use this to answer our question. Since our discriminant is a negative number, that means that there is no solution to this question. So to answer the question, can he catch the ball? No, it's not possible for him to catch the ball because we got a negative discriminant, which means there is no solution. So let's write that out as a sentence. It is not possible for him to catch the ball because the discriminant is negative, so no solution. Okay, so this is a really good real-world example of how to use the discriminant. Let's take a look at some other real-world examples. So I'm going to get my next real-world example from the textbook. We are in section 9.5, and we're going to follow along the monitoring progress question that goes with example 2. So if you want to take a quick look at example 2, pause the video and go in the online textbook and you can read through the problem, but it's pretty self-explanatory. It's just a real-world situation. They give you an equation and we're going to find the answer to it. I'm going to do monitoring progress question number 6. This is on page 517, in case if you wanted to follow along. So let's take a look at number 6. Number 6 says the number y of bald eagle nesting pairs in the state x years since 2000 can be modeled by the function y equals 0.34x squared plus 13.1x plus 51. Part A says when are there about 160 bald eagle nesting pairs? So the first thing that I need to notice is that this 160 stands for the bald eagle nesting pairs, and that represents y in our equation. So let's start by taking y equal to 160 and plugging it into our equation. We're going to have 160 equals 0.34x squared plus 13.1x plus 51. So now this is the equation that we're going to be solving. It says when were there about 160 bald eagle pairs? When is talking about our x. X is the year since 2000. So here, since I need to solve the equation for x, I need to use the quadratic formula. So no matter what, if I'm using the quadratic formula, I have to start with our equation equal to 0. So let's do that. I'm going to subtract 160 from both sides. And let's get our equation. We're going to have 0 equals 0.34x squared plus 13.1x plus, let's subtract these two. 51 minus 160 is negative 109. So let's say minus 109. All right, our equation is now in standard form, equal to 0. Here's my a, b, and c. Let's plug it into the quadratic formula. We're going to have x equals the opposite of b, so negative 13.1, plus or minus the square root of b squared, so 13.1 squared, minus 4 times our a, which is 0.34, times our c, which is negative 109, and this is all over 2 times our a, again, is 0.34. Okay, let's simplify. So I'm going to keep the negative 13.1 plus or minus, keep the square root. Let's simplify underneath the square root. So I'm actually just going to put all of this underneath the square root symbol into my calculator all together at the same time because my calculator can handle it. So we're going to do 13.1 squared minus 4 times 0.34 times negative 109. So I just typed it in exactly how it appears under the radical, and let's get our number underneath the radical here. We get 319.85, and then in our denominator, let's multiply 2 times 0.34 is going to be 0.68. Okay, our next step is we're going to take the square root of 319.85. So let's go down here. We're going to get x equals negative 13.1. Plus or minus, let's take the square root of 319.85 and let's round it to the hundredths place just because it seems like all the numbers here are rounded to the hundredths place here. So we'll do 17.88 and this is over 0.68. Okay, my next step would be to split this and get 2 answers to this. However, this is a real world problem. We're talking about time here, when. So I can only really have the positive answer. Let's think about which one would give us a positive answer. Is it the plus or is it the minus? Well, since negative 13.1 is smaller than 17.8, if I add it, the numerator will be positive, and a positive divided by a positive will be positive. So let's do that. We're going to do negative 13.1 plus 17.88, and let's divide that by 0.68. Okay, we're going to combine this together. In the numerator, let's do negative 13.1 plus 17.88. That's going to be 4.78, and then we can divide that by 0.68. And I get 7.03. Now here we're talking about when. So they're really thinking about years. X is the number of years. Let's round this to the nearest whole number. So this is really 7 years. But remember that we're talking about time since the year 2000. So 7 years after the year 2000, that's going to be the year 2007. So that's going to be our answer to part A. Okay, we're going to go on to part B. Part B now says, how many bald eagle nesting pairs were there in 2000? So now it's asking us to find Y. How many bald eagle nesting pairs? That's the Y. Were there in the year 2000? The 2000, that's going to tell us our X. So if X stands for the years since 2000, and we're talking about the year 2000, that means that X is going to be equal to 0. Let's plug that into our original equation from the beginning, and we'll find Y. Y equals 0.34 times 0 squared plus 13.1 times 0 plus 51. This just cancels out, this just cancels out, and we're left with 51. And we're talking about bald eagle nesting pairs. So I'm going to say 51 pairs.